set up collison with explosion. Use houdini 19. Use new pyro solver in obj level. Let's see the result. You can see the character have collision with the explosion. And another one, this one, we don't have any collision. So it looks like this. No collision, the character just came through this explosion. And this one, we have collision. And another topic is how to use volume well or gradient to advect particles points. Like this one, it's quite normal. This one is just use well to advect points. So it looks like this. Quite simple. Another one is this one. I use you can see the particle the shape is really difficult, different from the last one. Let's see. Same explosion, but we use a gradient and a well to advect these particles. You can see the particles they put together, put like the string things. So it's a different method. Okay, first let's see how to make collision with the character. It's quite easy. I use this tool. Simple effects. We use ground explosion for this one. Simple ground explosion. All default setting here. Default setting. Then you have to change something inside this pyro solver. Let's see how we set up the explosion with the character. First of all, we have a character here. We have a character here. See? Okay. The character will walk through this explosion. You see? And it's warm. Okay. Let's see our character. It's simple one. We use test crack. Test crack and convert to normal object, then subdivide two level. I guess one level. Then true compute velocity. After this, we use VDB from polygon, convert this to VDB, and also if you need this to make collider with pedal solver, you have to change this character to VDB. Also, the VDB value is the VDB volume is collision, and also you need the collision well to push the explosion. bear with me here because my computer is really lag with this heavy sim. See, we have the VDB from Polygon. Set this VDB as collision. Default is density or surface. We have to change to collision because the pyro solver it read conclusion. See conclusion. Then we have the trail, so we have the velocity here. See, we have the velocity here. So we can generate a volume called collision bell to as a velocity to volume as velocity to push the explosion. We have this volume and this volume. Then we cast out this. Okay, go back our sim. It's really easy, really easy. You just merge this obj merge the conclusion, then connect this second input, then change the conclusion as SDF plus volume velocity. We collision we have to read this collision and also velocity value is a collision value, so it will work. Then we can get this one without the conclusion, so it without this one we have conclusion. See this area, you can see, and you can set up the velocity scale. It will push more. Okay, this topic how to set up the conclusion with the pyro solver. Let's close this because computer is not good enough. Okay, another topic here, how to advect particles. The simple advection use POP advect by volume. We have this, right? Like we can file cast out this we file cache out this explosion. You can see we have the density, temperature, flame, and well. So we need the well to advect. Then we time shift. We get one from the explosion as a emitter with scatter points here. Then pop object, pop net. DOP network pop. We use this as our point. Then pop advect volume by well. You can see we swap level to this one of the explosion because we have the well. Then we can use the well in the pop. Then we have 3 of them, but you can choose. You can use force, treat as wind. You cannot treat it as wind. It's okay. And also you can choose another one as update velocity. It will have the blend. Use half of the velocity, or use the update pricing. We use the final velocity trace, then we can get get the result here. Get the result here. I already cached out, so you can see it's not heavy. So it's really normal because our explosion looks like this. So see here, our explosion looks like this. The particles from this here will advect by this volume. It's become like this. Let's see. It's this one. See, it's simply mimic the explosion movement, right? We use speed to set up the color. Speed is really easy. Fit the velocity length and get this color, next color. You can use different ones like this. See, and another one is here. We not only use velocity, we also compute the gradient. Here we have the density, temperature, flame well, but we need one volume called a gradient. How we get the gradient volume? Here we can see export level. We deport this, right? No gradient. But we already convert VDB. If you not convert VDB, you can simply use the volume analysis can generate the gradient. I use this. I already convert VDB and use 16-bit float. So I see here it's save a lot of cache space and driver space. So you can see it's VDB. It's not you can tell from the color, the normal volume. The normal volume, the color is this, and this color is like this. So we have to convert to volume, same color. See, color, and this color is like this, right? So we convert VDB and Houdini normal volume is two kind of volumetric thing in Houdini. And all the pyro we use Houdini traditional volume to film and to do the explosion or something, smoke, fire. But we use VDB as the solver sparse and smoke sparse thing. You can see here. Let me quick show you. It will just VDB is more efficient, more fast, sparse. Smoke sparse. This is VDB, and the smoke solver. This for the old volume. This for old volume. This for volume. This for VDB. VDB volume is it doesn't consider every voxel. It just active. The value bigger 0. Volume it will active all the volume even its 0 value. So it's really slow. That's why Houdini convert a houdini use new pyro solver as a VDB as sparse as VDB solver. We normally use this like pyro solver here. It's all new solver. It's use the VDB solver. It's more efficient, more speed here. You can use OBJ level. Also, you can use the top network volume. You can use sparse pyro solver sparse. It's the same thing, same thing. This same thing. So it doesn't matter. Here we have to convert this volume and use the volume analysis to get the gradient. Let's see the density. You can see density x, density y, density z. Before the volume analysis, it is density. It's just scalar density. Now we have vector density. We have three separate volume x, y, z. That's we need. So we call this after gradient. Let's copy this. Then this one, we not only use the val, we also use the outer gradient. Copy here, right? Gradient. We use the density because the density we have the velocity value in density is the gradient. So same setting, but we just use 0.2 velocity scale to get the result. Normally, it's default value is y. Normally, it's too strong. You can set 0.2, 0.1. I use 0.2. What's the different val and gradient? You will let's quickly. I'm not sure I can explain well, but let's see. Okay, we have volume here, like this one. We have volume here, right? It's a volume. We have volume here, and the true is easier for it's easier for this. It's easier for this. So we have this, right? The velocity is easier. It's like out. Let's scale some points. Let's see the velocity. See this velocity, and if points advect by the velocity, it like this explosion. It will from this emitter, these points will outside out like the velocity will shoot out from this point. It looks like this. It looks like this, right? The velocity will push the points, make extension really big. And gradient is like see here, this core inside this is density is higher and outside is low. So a gradient like this, the lower volume will towards a higher volume, like a velocity, like will have the velocity, like the like here, like here, will inside this with a lot of volume will from outside pull inside this and this as well. So we use these two, one gradient, one gradient, one velocity, well, one gradient will get this result. We get this result. First, the well will push, it will extend really big. Then you can see this line will become linear. This small mushrooms have the gradient from outside push inside, so it looks like this. It's like a spider web, right? So it's kind of cool, right? It's kind of cool. And we use the DOP network to get this kind of result. One use one use well and gradient. Another method here. I get this one. You can see it's points, right? Points, a lot of points, right? Same with this, same with this. But you can tell I didn't use any POP network. I didn't use particle to get this. How I set this? Let's see. It's quite easy. We have the pyro solver. Then back inside here. This volume collision I didn't use for this purpose. Okay, we don't need. We can ignore this. I just use the pyro solver. We have three input. One is advect. So I have gas advect. We use this to advect well. Also, you can another one like gas advect use the geometry PTS. We put PTS points and we use density 0.2, merge them together. We can get the same result. We can get the same result like this as well. We can get the same result this one. Okay, first we don't set this. Okay, then one is advect output and one is source output, one is false output. We use the SOP solver to get the false updated. How to set this? Quite easy. We have to cast a few frames. Let's wait a sec. If I speak Chinese, it's way easier for me because English is not so good enough. But I will update this to YouTube channel, so I have to speak English. If I update to, then we have the point you can see here. Let's see inside how we can get this. First, we solver, create a new one. It will, okay. Then we can get the geometry normally, right? Because outside is the geometry. For this one, we called as PTS. So we got the PTS here. Yes. Another, we got the density. We can tap density here. We can get the density. Okay. We need solve again. Let's see. 5 easier, faster. Normally we cash out. We didn't get the points, but you can see we get the points right here. See here, we just export the point PTS. We didn't check the other density or something. So you can see we get the points here. Okay, then we have points here. It's points. And we have density. We use this density, scatters points. Every frame will scatter 25,000. And we use integer age set to 0, then increment the age by every frame will plus 1. Later we use the integer age attribute to set the color or render something. It's not affect our result, so it's not really important. Here we have the PTS, we have the points, every frame with the points, and merge together. You can get the points and velocity. And we have the value. You can set a value. Every frame will get the value, right? And because the value we have convert to VDB, then we VDB vector merge. We can merge well their x, well their y, well their z to one channel. See, well, we use this well to get for the point to get the velocity. Then attribute from volume node. One input for point, one input for the velocity, volume. Then you have the points will have the velocity here. See, too many points. It's too slow. Okay, wait. And this we get temperature, we attribute from volume, we make the point have the temperature, then we got the flame, we every points will have the flame value, then we color by the flame because we can see the flame here 0 to almost 4, so 0, 4 flame. Actually, you can output this. It doesn't matter. You can output this thing. You can output. I mean here you can output, right? Cache out this point. It looks like this. This all points. It will have the flame, age, and the velocity. You can see the age value. See, every frame will add one. And you can see the temperature value, a flame value. So we use the flame set color. See, 4 or 2, we set 2. It looks like this. This method advect by SOAP server. Also, we need this gas advect connect the advect output. Also, you can connect this here, like merge them together. It doesn't matter. You can click here. It's all good. So I normally will click here because our advect output, right? This force output, we add force. We already add the velocity to our points. Then we need velocity to advect this point. So gas advect val to PTS. Then we can set the scale velocity. Then you can get this, and you can get this, right? It's similar this one. It different because the color is different. Also the points amount is different. It's more. This is the same. This is not the same points. This more points similar with this one. See, similar. Compare is not looks like the same, but this method is more accurate. The explosion, because every frame it will have the point. It will look like this. See, I can see compare this. It's not, because we just output here a few frames or points. One frame, this. And not one frame, this different frames. So these two methods to advect the points. You can use pyro solver, SOAP solver to advect. Also, you can use the POP network. Okay, that's all. Thank you, everyone. 如果我说中文的话，我可能解释的更清楚一点，因为我还要思考，然后还要想怎么表达。而且我也没有剪辑啊，我没有时间剪辑，因为工作比较忙，所以只是记录一下，然后我希望自己不要忘记，以后我需要做一些东西的时候，比如我们最近的需要有一个新的项目，就是船在海里游动，然后我可以把船作为一个物体，然后从船周围我给飘过的地方，我发射一些烟雾，然后通过这个烟雾来驱动particles，然后让这个海里 那个尘颗粒啊，那种感觉。